Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nuratika binti Mawazim. I'm going to present you my final year project title, which is Phytochemical Investigation of the Stem Bark of Anisoptera Laevis. I'm supervised by Dr. Aisyah Salihah bin Kamaruzaman. To know what Anisoptera Laevis is, first we need to know it came from the family of Dipterocarpaceae. What is Dipterocarpaceae? Dipterocarpaceae is a tropical plant family that forms a major component of low-lying rainforests in Southeast Asia. And the timbers of Dipterocarpaceae family is well liked because they are hardwood type of timber which have high durability, which make it important in housemaking and furniture manufacturing. Now, Anisoptera is actually a genus under the Dipterocarpaceae family. There are 10 species of Anisoptera, as you can see here, which is A. aurea, A. costata, A. corticii, A. glossivania, A. marginata, A. magistocarpa, A. reticulata, A. scapula, and A. turifera. Anisoptera Laevis, locally known as merawan or mersawa durian and pinggiran durian. The Greek name of anisos, which means unequal, pteron means wings because it has unequal wings, like 5. Then medicinally, locals use Anisoptera Laevis to treat ear problems, hemorrhoid, diarrhea, antiemetic, and wounds. As you can see over here, this is the chemical constituent from Anisoptera, not specifically from Anisoptera Laevis, just the genus of Anisoptera. There are 9 chemical constituents. We have uponaphenol L, transpicid, vaticanol B, cispicid, resveratrol, soracetone, uponoside C, diptoindonacin A, pauciflora B. All of these are some way or another result in antifungal, antibacterial, antiviral, anti-inflammatory, cytotoxic, and antitumor effect, as described by Rohan et al. 2014. As we are discussing the activities from Anisoptera, this is the biological activities for Anisoptera. In Anisoptera, there are tetramethyl being isolated from Anisoptera species, which exhibit a wide range of biological activities, including antifungal, antibacterial, antiviral, anti-inflammatory, cytotoxic, and anti-tumor effects. Cytotoxic, which is toxic to harmful cell, and anti-tumor is fight off tumor. In particular, A. costata and A. corticii have demonstrated antifungal, antimicrobial, antiviral, anti-inflammatory, and cytotoxic activities. Stilbenoids in Anisoptera function as phytoalexid, playing an important role in plant defense against pathogens and insects through their antimicrobial and insect repellent properties, which studied further in A. costata, A. turifera, and A. scapula, that have shown that this species possess alpha-glucosidase inhibitory and antioxidant activities, suggesting that they are potential as anti-diabetic agents, which means they control the sugar in your body. For the starters, we discuss about the problem statement in this case study in this thesis, which is previous studies have shown that Anisoptera genus is rich in oligostilbenoids, stilbene dimers, and tetramers, which act as phytoalexin and possess antiviral, antifungal, antioxidant, antimicrobial, and anti-inflammatory properties. However, the phytochemical constituent of the stem bark of Anisoptera Laevis remain limited. Therefore, this study was carried out to investigate and identify the bioactive component present in the stem bark. As you can see over here, the objective is to isolate the phytochemical constituent from standby of Anisoptera Laevis using several chromatographic method. And next, to perform a structural elucidation of the isolated compound by employing Fourier Transform Infrared spectrometry and Ultraviolet UV-Vis. We now have reached the methodology of Anisoptera Laevis. Now, as you can see here from the beginning, the Anisoptera Laevis, the tree, is the earlier set is like a buttress root, right? Then from the stem bark of that tree, we get we maceration it into powder, which around 900 gram. When underwent cold extraction of acetone for 24 hours, repeated 3 times, then we obtain acetone crude extract, which is 65.42 gram. Then from that crude extract, we undergoes another extraction through VLC and with the solvent of HEA. Then we get L1, L2, L3 and 4. These 4 fraction. And we concentrated in the studies, we concentrated on L2, which is 560 milligram. It underwent another extraction through column chromatography, solvent of chloroform ethyl acetate. Then from there we obtain the fraction 25 with the weight of 3.1 milligram, which is our compound 1. We're going to discuss the result discussion here about compound L225 earlier, which is weight of 0.003162 gram, was obtained as a brown amorphous solid from the stem bark of Anisoptera Laevis. As you can see over here, we have 3 reading, which is 260 to 83. The absorption band, if you can see over here, at 283, indicating the presence of extended aromatic conjugated system, which is present in Anisoptera. As we can see here on IR spectrum, we focus on several wave number, which functional group is OH stretching, aliphatic CH stretching, aromatic C double bond C stretching, C minus O stretching, and aromatic CH out of plane bending. Okay, why OH stretching? Because indicate the presence of numerous phenolic hydroxyl group, which are characteristic of steel banded compounds, while the aliphatic CH stretching suggests the presence of saturated carbon atom, particularly the methane carbon. Aromatic C double bond C stretching confirm the presence of conjugated aromatic rings. The C minus CO stretching confirm the presence of phenolic alcohol group attached to the aromatic ring. And lastly, aromatic CH out of plane bending, because it gives information about substitution pattern of the benzene ring. This is another elucidation in HNMR spectrum for compound L225. We can see here there are 4 types from certain region: para-substitute benzene rings A1, B1, C1 and D1 at region 6.56 until 7.35 ppm. Substitute benzene rings A2, B2, C2 and D2 is at 6.8 ppm. Dihydrofuran rings 5.2 until 5.8 ppm. And lastly, oxygenated aliphatic methane, which on the right side, which 4.1 and 4.7 ppm. Last but not least, on result and discussion, elucidation on C-APT-NMR spectrum for compound L225. As we can see here, there are downfield regions which are on the left, then outfield regions which are more shielded on the right. In downfield region, we have oxyaryl carbon 140 until 160 ppm, quaternary aromatic carbon 110 until 135 ppm, and we look over to the right on the upfield region. There's oxygenated methane carbons 85 until 130 ppm. All of this discussion it is identified by comparison of a spectroscopic data with the literature reported by Tanaka et al. 2000. In conclusion, the phytochemical study of the stem bark of Anisoptera Laevis has successfully isolated a terrestrial steel benoid named as vaticanol B. But as the benoid have been reported to possess various biological activities, including antioxidant, antimicrobial, anti-inflammatory, and cytotoxic properties, the presence of vaticanol B highlights the potential of A. laevis and Anisoptera laevis as a valuable natural source of bioactive compound. Overall, this study provides useful scientific information that may serve as a foundation for future phytochemical and pharmacological investigation of this species. That's all from me. Thank you for listening.